Guys, did we do any problem on depression and freezing point?
No, sir.
No. Okay, fine. So I think we should start with the problem in depression freezing point, and then we can move towards osmotic pressure. Okay, write a question. (1.02 gram of urea when dissolved in 98.5 grams of certain solvent certain solvent 1.02 gram of urea when dissolved in 98.5 gram of certain solvent decreases its frequency decreases its freezing point by 0.211 Kelvin by 0.211 Kelvin. Now 1.6 grams of unknown compound when dissolved in 86 grams of the same solvent decreases the freezing point by 0.34 kelvins. Okay, so we have two situations. In the first situation we are adding urea. In the second situation we are adding an unknown compound, but both of the solute they are added in the same solvent. They are added in the same solvent, and the depression and freezing point for both the cases has been given. The first case has 0.021 and the other case has 0.034 kelvins. Okay, they are asking calculate the molar mass of the unknown compound. Okay, please write this question. All of you wrote the question, yes or no? Yes, Sarah, Abdurrahman, Fatima, Huzaifa.
Yes, sir.
Okay. Now, see, in the first case, they have given us 1.02 gram of urea plus 98.5 gram of solvent, and the delta TF is 0.211. The delta TF is 0.211. Now, in this, from this information, what I can calculate, see, what is delta TF is equal to? Tell me. Kf into Kf in molality. Yeah, small m, right. Now we can also write Kf into the number of moles of solute divided by what? Divided by mass of solvent in kg. Furthermore, I can write this as Kf into Nb can be written as Wb upon the molar mass of solute into the mass of solvent in kg, delta Tf. Okay. Now, can you see delta Tf is given? Yes or no? Please tell me. Delta Tf is given? Yes or no? Right? Acha. Wa in kg you can find out, right? It is given in grams. Correct? Yes or no? Is that right? Wa is given, yes or no? Please, I need answers. Sara, Fatima, Huzaifa, Artiel, Abdurrahman, please answer me. Is Wa given, yes or no? Mass of solvent.
Yes.
What about others? आप लोगों ने लिखा है. Yes, Sara, Fatima, Huzaifa. Okay.
Yeah,
What it's given, right? What about the mass of solute? It is given, yes or no?
yes, sir.
Okay. And the molar mass of solute urea, it is also given, right? Urea is what? Urea has a formula of. Does anyone know what's the formula for urea? CONH2 NH2. Okay. CONH2 NH2. And it must be given in this question only. So please write this with me here only. Molar mass of urea is equal to 60 grams per mole. Now, as you can see, molar mass is also given. Now, can you calculate Kf? Yes or no? Please tell me, guys. Can you guys calculate Kf? Yes or no? Okay. So we will calculate the Kf from here, and then we will put this Kf in the case 2. And from there, we will calculate the molar mass of the unknown compound. Molar mass of the unknown compound. Here is that molar mass of the unknown compound, which we have to calculate. Okay. Calculate the molar mass of the unknown compound. First of all, you have to calculate the Kf from the case 1. Calculate the Kf from the case 1. 2.11 is in Kelvin. 60 is grams per mole. Into there is kg here. Divided by 1.02 grams. It is in grams here. Grams and grams will cancel each other. You will get the unit as Kelvin kg per mole, right? And that is the unit of Kf also. That means we are going in the right direction. You just need to solve this. Now, whenever you are solving, I hope you know how to solve the decimals. You have to get rid of the decimals. Yes or no, guys? Get rid of the decimals and then solve it. Check your decimal points. Josefa, check your decimal points. I think your number is fine, but the decimal point is not correct, Josefa. Anyone else who got the answer? No, Adriel. No. So, okay, see here. This can be 211 into 10 to the power minus 3 into 60 into 985 into 10 to the power minus 4 divided by 102 into 10 to the power minus 2. Is this clear with everyone? Yes or no? Please tell me. Till here, everything is fine. Josefa, now it is fine. Adriel, now it is fine. Okay. Okay, Josefa and Adriel. Okay, both of you guys did not write the decimal point at the correct places. Okay, still waiting for Sarah, Fatima, Abdul Rahman. Yes, Sarah, correct. Abdul Rahman and Fatima. Yes, Abdul Rahman. What about Fatima Ansari? Fatima, are you there? Am I audible?
Yes, sir.
You're still solving it?
Yes, sir.
Okay, fine. Solve it, okay? You will get some answer. It will be in Kelvin kg per mole. Okay. Those who have got the KF, they can write the case too. Okay, in the second experiment, what is happening? Sarah, can you please read that line out? How much gram of unknown compound is dissolved? Yes, Sarah?
1.6 gram
1.6 grams of, please completely read it now. 1.6 gram of
unknown compound when dissolved in 86
wait, I'm writing unknown compound in 86
of
grams,
86 gram of the same solvent.
same solvent. And the decrease in freezing point is how much? Delta TF is
0.34 Kelvin.
0.34 Kelvin. Okay. So here also the same thing. Delta TF, it will be equal to what? It will be equal to KF into WB upon MB into WA into kg, right? And from here, see, you have got the value of KF, right? You also have the value of delta TF, that is 0.34. You have the WB, 1.6 grams. You have the MB. No, you don't have the MB. What do you have? You have WA in kg. 86 grams that you can convert it to kg. And from here, you can calculate the molar mass of the unknown compound. So molar mass of the unknown compound, it will be equal to what? It will be equal to KF into WB divided by delta TF into MB. No, not MB. Delta TF into WA in kg. Chaliye, please write this down. Solve for this. फातिमा अंसारी, हाँ तो इसको सॉल्व कीजिए ना, फिर आगे कितना आएगा बताइए. व्हाट डू यू हैव? You have 1, 2, 2, 2, 5, 5 into 10 to the power minus 5. So 1, 2, 3, 4, 5, right? So you will get 1.22. Yes or no?
Yes, sir.
That's the right answer, correct. This will be 1.22 Kelvin kg per mole. Just need to plug in the value here. MB will be equal to 1.22 into WB is 1.6 grams divided by delta TF is 0.34 Kelvin into WA in kg will be equal to 0.086. 0.086 को सच्चा क्या लिख सकते हैं हम लोग 86 upon 1000 and we can multiply 1000 here rather. Okay, चलिए solve for this. Let me know what is the molar mass. So you can write it like this now. 122 into 16. 1000 as you can see, it can 3 zeros are here now and we have 3 decimal points. 0.34 into 86. Furthermore, you can write it as Okay, let us see Abdul Rahman. I think that should be the answer. Or somewhere near that. Okay, Sarah is also getting the same answer. I think that is fine. Okay, what about others, huh? Matthew? No, Matthew is not. Adriel, Josefa, Sarah, Fatima. Sarah has given the answer. Waiting for Adil, Fatima, and Huzaifa. Sara and Abdurrahman has given the answer. No, Adriel. Please check your decimal point. Okay, it's fine now. I mean, it's near bit fine. It should be 66.75 grams per mole. Okay, you must have done some mistake in the calculation, but it's still approximately correct.
Sir, I took KF as 1.21.
You 1.21. Okay, maybe that is the reason you're getting a bit lower value. Okay, Fatima, done?
Yes, sir.
Yes. Okay, fine. So see, this is the type of question that you will be getting, and the other type of question will be very similar to what you have done in elevation in boiling point also. Okay, but this type of question in which you have to calculate the KF from a certain case, and then you have to calculate the molar mass from a certain case. These type of question, it will be asked in 3 marks type. Okay, in CBSE, this type of question will be asked in 3 marks. Okay, the other question they will be asked in 2 marks. Okay, and if you have, for example, the molar mass question, they will be asked in 2 marks, and the delta TF questions, that means you have to calculate only the freezing depression in freezing point. Those will be asked only for 1 mark. Okay, so please keep in mind what type of questions are asked in what type of marking also. Next topic is osmotic pressure and osmosis. But before that, I want to discuss a thing. And I have few questions for you guys. Let us suppose we have 2 containers. Okay, and in these containers, don't write anything. Okay, just listen here. There's a container A and container B. In container A, we only have solvent. In container B, we have solvent as well as some solid solute. What type of solute is there? Please tell me. What type of solute is there?
Solid solute.
Solid solute is there. Okay. The first question is, which solution will have, or rather which liquid will have higher vapor pressure, A or B? Answer me in chat. Which will have higher vapor pressure, A or B? A or B? Okay, Abdul Rahman. Okay, Fatima Ansari. Waiting for Adriel, Sara, Josefa. Okay, Sara. Josefa, what do you think? Okay, Adriel thinks B. Okay. Josefa, what about you? Okay. Okay, Fatima, can you explain me what is your answer and why is that your answer?
Sir, it is A solution will have more vapor pressure because in the B solution there is solid solvent which won't have vapor.
Ah, okay. Sara, you want to add something? Sara?
The
But-
solid
Hmm.
solute will, like, the intermolecular force will be more in the B solution. That's what I thought.
No, I have not specified that, no, but why do you think like okay, it can be that is one other case, but you cannot be very sure, na, that if I am adding some solid solute, it will be more. Huh? That means you guys have not. अच्छा, क्या कहा था हमने कहाँ तक prepare करके आने के लिए? What is this topic? Tell me. What is this topic?
Lowering of vapor pressure.
Relative lowering of vapor pressure. What is relative lowering of vapor pressure? Tell me. Adrian, tell me. Adriel. Adriel, you have written notes now for relative lowering of vapor pressure. Now I'm not getting any answers from you. Huh? Yes, Adriel, tell me. Yes, Adriel. No. Abdul Rahman, you tell me what is your answer and why is that your answer?
So why
Yes, sir.
my answer is A? You're asking that.
Yeah, correct, exactly.
So because in the container there is only solvent, so the forces are very weak, and then vapor escapes more easily.
Okay. All of you turn your pages back and come to the topic relative lowering of vapor pressure. Please fast. Turn your pages back and in your notes, you have to look at the notes part where you have relative lowering of vapor pressure, RLVP. Let me know when you are there.
Yes, sir.
Can you read what is the relative lowering of vapor pressure? Yes, Abdul Rahman, can you please read aloud what is the relative lowering of vapor pressure?
When a non-volatile solute is dissolved in solvent, the vapor pressure of solution decreases and becomes lower than that of the pure solvents. This is known as relative lowering of vapor pressure.
Did everyone hear this? Yes or no?
Yes, sir.
Yes. Okay. Is there any mention of intermolecular forces of attraction here?
No, sir.
Mm.
No, right? What is the reason then? What is the reason then?
Sir, non-volatile solute.
Non-volatile solute. So what does the non-volatile solute do? It again, see, when I will speak the reason, you will just remember that I have said this earlier also. It occupies some area of the surface and it hinders the vaporization of solvent particles. Is that right? Yes or no? Please tell me.
Yes, sir.
Okay. So what is the reason, Sarah?
Non-volatile solute.
It occupies some area in the surface and it hinders the vaporization of solvent particles. That is why it leads to the lowering of vapor pressure. Please remember these points. Okay. आपका तो वाइवा था and this still you are not answering the correct thing. That means you have not read the notes. So first thing is that which will have lower vapor pressure, A will have lower vapor, sorry, which will have higher vapor pressure, A will have higher vapor pressure. Now, here we are having vapor pressure which is higher. And what will happen if I connect these two? What is going to happen if I will connect these two and it will apply a kind of, I will apply kind of a semi-permeable membrane, and this semi-permeable membrane, it only Semi-permeable membrane, it only allows the solvent molecules to pass over. The solvent molecules to pass over. It doesn't allow the solvent particles to pass over. Now, when the vapor pressure is higher at this point, there will be high vapor pressure which will be acting on this part of the container, and this compartment will be having lower vapor pressure. That means the solvent particle will move from A to B. Is this clear? Yes or no? Please tell me. When you apply a higher pressure, if the pressure is high at one of the compartment, what will happen? If this solvent particles, they will experience a force, and this force will lead to the movement of solvent particles from A to B. Is that correct? Yes or no?
Yes.
Is everyone fine with this? Yes or no? Tell me.
Sir, can you repeat?
What do we have here? We have high vapor pressure or low vapor pressure in the A compartment?
Sir,
High vapor pressure. Now, when there is high vapor pressure in the A compartment, that means the solvent molecules, it will be experiencing some force, right? What is pressure? Force upon area, right? Correct?
yes.
Now, if they are experiencing a force, then they will move. Anna? And where will they move? They move into this compartment, and they will be moving. And they will be moving until and unless the vapor pressure or the pressure between these two compartments are equal. Because as the amount of solvent will increase in the B compartment, what will happen? The vapor pressure of the B compartment will also tend to increase, right? And when the vapor pressure in the A compartment and the B compartment, they will become equal, this flow will stop. Correct, Abdur Rahman?
Yes, sir.
Right. When you have disbalances of forces, then what will happen? Things will start moving, correct?
Yes, sir.
Anna? And when the the movement will stop only and only when the vapor pressure are, or whatever the pressure in this compartment and the A compartment, when they are equal, the osmosis, the movement will stop. Okay, this movement is known as osmosis. The movement of solvent, the movement of what? Solvent from a lower concentration. If you have only solvent, that means the solute is not present. And if the solute is not present, that means the concentration of that solution is what? Low. From a low concentration, from a solution of low concentration towards a solution of high concentration. Okay, so this movement is known as osmosis. Now, please listen very carefully. If I apply a very appropriate pressure, okay, on the B compartment, on which compartment? Where am I applying the pressure?
B compartment.
B compartment. Okay, I'm applying pressure on the B compartment. Now, I apply such a pressure that this pressure and the vapor pressure which was present at B, they both add up and they become equal to the vapor pressure of A. That means what I have done essentially, I have equalized the pressure in the B compartment and the A compartment by adding some external pressure. Is that clear? Yes or no?
Yes.
What I have done, I have applied pressure, and I have applied that much pressure which equalizes the pressure of A. And now what has happened after this? After applying this external pressure, the vapor pressure is equal to the vapor pressure of B. Now this flow will stop, yes or no? When the pressures are equal, the flow will stop. And this external pressure which stops the osmosis or which stops the movement or the flow of solvent molecule, it is known as osmotic pressure. Okay, so the osmotic pressure is the pressure that is applied in order to stop the osmosis. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay, so first thing first. See, due to the difference in vapor pressure, what happens? Due to the difference in vapor pressure, the solvent molecule, it flows, and it flows from a solution of low concentration towards a high concentration. And low concentration of what? Low concentration of solute to high concentration of solute. And in order to stop this flow, we apply a pressure, and this pressure is known as what? This pressure is known as osmotic pressure. Okay, so please remember this very small portion conceptually. Difference in vapor pressure leads to the movement of solute from the movement of solvent from low concentration to high concentration, and the pressure applied in order to stop this flow is known as the osmotic pressure. Now let us write the definitions and the formal definitions and etc. for osmosis. Please write the topic osmosis and osmotic pressure. All of you understood what is the concept in osmosis and osmotic pressure? Yes or no? Please tell me. We just need to write it down. Okay. All of you write this. Now, these definitions are very important because they have directly been asked in CBSE examination. Please write the process of flow of solvent molecules from a solution of low concentration of solute to a solution of solute, you just keep in bracket, to a solution of high concentration of solute through a semi-permeable membrane is known as osmosis. Okay, the definition of osmosis has been asked in the board examinations in 2011, 13, and 15 also. Okay, so please write this down. The next statement, the next definition that I will be writing is the definition of osmotic pressure. So please write the hydrostatic pressure which develops on the account of osmosis is called osmotic pressure. Okay, now this is more of a physics kind of definition, and the definition which is required in terms of measurement of osmotic pressure. But in the examination, what you will write this definition that is in 3-star. Okay, so please write the pressure which just stops the flow of solvent. In bracket you can write that is osmosis. The pressure which just stops the flow of solvent is called osmotic pressure. Clear? Yes or no? Please tell me. So please write this down. Let me know when you're done. Done all of you? Yes or no? Please tell me.
Yes, sir.
Yes. What about others? Adriel, Fatima, Josepha, Sarah?
Done, sir.
Done? Okay. Everyone is done. Now, let us suppose we have okay, so this is my semi-permeable membrane. Okay, this black line is my semi-permeable membrane. Okay, now I have again two compartments, right? I have compartment A and compartment B, and let us suppose we have 0.1 molar. Let me write it not here, rather here. 0.1 molar solution in the A compartment, and we have 0.3 molar in the B compartment. Now you have to tell me the solvent will flow one A to B or B to A. Write in chat. 1 or 2. What do you think? A is 0.1 molar and B is 0.3 molar. Okay. Okay, Fatima. Okay, Abdurrahman. Waiting for Josefa, Sarah. Please, if you are confused, tukka mat mariega, please. ठीक है? Please read the definition of osmosis. please read the definition of osmosis and then try to answer. Okay. Fatima and Abdurrahman, correct. Adriel, correct. Don't rush. Okay. Also, don't rush. Take your time. Read the definition 2 or 3 times if you don't understand, and then tell the answer. So you're waiting for Josefa and Sarah. Okay, Sarah, correct. Yes, Josefa, can you please explain your answer? Josefa, can you please turn the mic on and explain your answer? Josefa, can you please turn the mic on? Is it possible?
Yes. Yes, sir.
Please read. Can you please read the definition of osmosis? यहाँ से read कीजिए चलिए है ना? Please read here. The process of
The process of flow of solvent molecules from a solution of low concentration of
what? Sorry, Rama.
Yes, sir.
From a solution of,
Low concentration.
and what did you write in the chat?
Yes, sir.
What is this? हाँ, खा पी के बैठा कीजिए, कहाँ दिमाग है आपका? Josefa, you want to change your answer now?
Yes.
Obviously, right? You have to change. अभी
Yes,
भी
sir.
change नहीं कीजिए तो फिर हो गया. Okay, fine. So all of you agree that the solvent will flow from A to B, correct? Yes or no?
Yes.
Yes or no? Okay, fine. Now in the second one also, it will flow from one A to B. Is that correct? Yes or no? Please tell me. A to B, right? In the second case, tell me. This is the first case, case 1. And in case 2? Array, what happened? The solvent will flow from A to B, right?
A to B, yeah.
A to B, ना? हाँ, हुज़ैफा आप बताइए. हुज़ैफा,
Yes, sir.
right? A to B. Okay, fine.
Yes.
Now you have a different question. Okay, now you have a different question. The flow of solvent will be faster in case 1 or case 2. Chaliye, write the answer in chat. The flow of solvent will be faster in case 1 or case 2. Okay, I will just pause for a few minutes. Okay, try to figure it out. Case 1 or case 2. You all can figure it out. Okay, but just try to figure it out without my help. What happened? I've only got answer from Fatima and Adriel. Abdurrahman, Huzaifa, Sarah. Sarah, what do you think? Where will it be faster? Sarah? I can't hear you. Okay. Abdurrahman, what do you think? Where will it be faster? Okay. So VP1 and VP2 are the vapor pressure of the B compartment in case 1 and case 2. Is that clear? Yes or no? Please tell me.
Yes, sir.
ठीक है, अब ये बताइए which of them is higher and which of them is lower? VP1 क्या है?
2 is
Is it
higher.
2 will be higher?
Yeah.
Okay, why? अरे देखिए आप लोग ना, देखिए फिर से हम बता रहे हैं वेपर प्रेशर क्या है. What is vapor pressure and which component is responsible for vapor pressure? Liquid या solid?
Liquid.
Again, all of you please turn the mic on and tell me which is responsible for vapor pressure, liquid or solid? Adriel, Huzaifa, Sarah, Abdurrahman. Which component is responsible for vapor pressure? What happened, Abdurrahman? Yes, Abdurrahman.
Yes, sir.
Tell me which of the vapor pressure is higher, 1 or 2?
Sir, 1.
Okay, Sarah, tell me which of the vapor pressure is higher, 1 or 2? Sarah. Huzaifa, tell me. Fatima, tell me. Fatima said. Adriel, tell me.
Yes, sir.
What did I ask, Sarah? आपने सवाल भी नहीं सुना क्या?
Two.
Sorry?
In the case 2.
The case 2. Okay, now you tell me what is responsible for vapor pressure, liquid or solid?
Liquid.
Liquid. And now please keep your mic on, Sarah. Please keep your mic on. If you have 0.5 molar and 0.3 molar, in which of the case do we have more solid? If the solute, in both the cases, the solute will be solid solute, right? We are taking the case of solid solute only. Now you tell me which of the following case will have more solid solute? The first one or the second one?
Second one.
If second one has more solid solute, that means it has less solvent, right?
Yes, sir.
So now tell me which will be having greater vapor pressure.
Case 1.
Now you tell me, why did you say case 2?
I was not sure.
Okay, you are not sure. Then, like, how do you answer then if you're not sure? Always try to keep asking some questions like this. Now, what is responsible for vapor pressure, right? And whenever I ask what is lower and higher and these type of things, you have to ask these things. Okay. So vapor pressure of 1 is higher than vapor pressure of 2. Okay, so vapor pressure of 1 is higher than vapor pressure of 2. And the vapor pressure in both the cases here and here, it will be same because it is 0.1 molar, 0.1 molar. Now, what do you think? Where will be the difference higher? Tell me. Vapor pressure 1 is high, so it will be near to vapor pressure, right? And vapor pressure 2 is low. That means the difference in these two cases will be, the difference will be greater. The difference will be greater. And also one more thing you have to understand. Now, I don't know why I'm explaining this once again. That when you have, please listen this very carefully. Please listen this very carefully. What is responsible for the osmosis? What is responsible for the osmosis? The difference in the concentration, right? If the difference in concentration is high, that means the flow will be faster. Yes or no? Huh? Tell me. Many of you answered. For example, Huzaifa, you tell me, what is responsible for osmosis? The difference in concentration terms, right? Huzaifa, can you please answer?
Yes, yes, sir.
Why do you think? What is responsible for osmosis?
Concentration.
Concentration. Now, if the difference in concentration that is very much high, that means the osmosis will be very fast, right? If you have equal concentration, Josefa, will there be any osmosis?
No, sir.
No, right? That means osmosis. The difference in concentration is responsible for osmosis, है ना? And
Yeah.
if you have a high difference in concentration, the flow will be faster. Easy.
Yes, sir.
Is this clear with everyone? Sarah, Fatima, Adriel, Abdurrahman. Abdurrahman said the right answer, I think. Yes. What about others? Yes, Sarah, Fatima. Sarah and Fatima, can I please?
Yes, sir, it's clear.
Sir, no, sir. Okay, now explain me. Fatima, tell me. What is clear?
Which one will be faster?
बताइए कौन सा फास्ट होगा 1 या 2?
2 will be faster.
2 will be faster. Why? Because
the osmosis depends on the concentration.
The difference in concentration, and if the difference in concentration is higher, the osmosis will be
Faster.
Now you tell me, if the osmosis is faster in the second case, right? In order to stop the osmosis, I will have to put some pressure. Let us say this is P1 and this is P1 and P2 are the pressure that is applied in order to stop the osmosis. So P1 and P2 does what? It stops the
Osmosis.
Now tell me, if the flow is faster here, do I need to apply more pressure or less pressure?
More pressure.
More pressure. Is this clear with everyone? Yes or no? Sarah, Adil, Abdurrahman, Huzaifa?
Yes, sir.
Yes? Okay, fine. Now this pressure is the pressure that stops the osmosis. That means it is the osmotic pressure, correct? And we have seen that osmotic pressure is higher when this concentration is higher. That means I can see osmotic pressure is directly proportional to concentration. Clear hai? Yes or no? Please tell me.
Yes, sir.
Chali. Now write the topic. Just write like this. For a solution of non-volatile solute, pi is directly proportional to concentration. And the concentration term that is directly proportional to pi was found out to be molarity. Okay. And what is molarity? Molarity is number of moles of solute divided by volume. And when we write the equality sign and remove the proportionality sign, we get NB upon V into the constants were R into T. Okay. It is similar as, see, if I put the volume this side, I will get pi. Pi is what? It is the pressure into volume is equal to nRT. Okay, so it is very similar to the equation of ideal gas, that is PV is equal to nRT. And also because we are dealing with vapor pressure due to gases, that is why you get a similar equation here also. So we can write pi is what? Is equal to CRT. What is C here? C is the molarity. Okay, C is the molarity. Pi is the osmotic pressure. Pi is what? Osmotic pressure. Please write this down. Let me know when you are done. Is everyone done? Yes or no?
Yes, sir.
Now write the topic, determination of molar mass using osmotic pressure. Determination of molar mass using osmotic pressure. Please write with me. We all know pi is equal to CRT. C is what? Number of moles divided by volume into RT. Pi, it will be equal to NB is what? The given mass divided by the molar mass of the solute into V into RT. We can write MB will be equal to WB into RT upon pi into B, that is volume. Okay, so from this we can calculate the molar mass using osmotic pressure. Write a note. Osmotic pressure is used to calculate the molar mass of macromolecules. Macromolecules means big molecules. Macromolecules like polymers and proteins. Okay, why? But due to ease of measurement and ease of measurement, it accompanies many points that you can elaborate on. Ease of measurement, that means it can be measured at room temperature, and what are we using? We are using molarity, which is a comparatively simpler concentration term. We use molarity rather than molality. Okay, so these are the main two things: ease of measurement and also accuracy. Accuracy means when we are going to measure osmotic pressure, the measurement is high. Okay, measurement is high. Okay, अभी आ रहे हैं. अस्सलाम वालेकुम मोहम्मद उमर.
वालेकुम सलाम sir.
बड़ी देर कर दी मेहरबान आते आते. What happened, huh?
Yes, sir, I'm not well today.
What happened? Oh, sorry.
Sir, influenza.
Influenza.
Yeah, yes.
Okay. So did you visit to the doctor?
Not today. I will be going tomorrow, perhaps.
Okay. Get your vitamin D tested also.
Okay, sure.
Okay.
Yeah.
Because like in my little tiny brain, influenza is just like lack of immunity. So, and immunity is like directly proportional to like how much vitamin D you are getting. So that is why I'm asking. It may be one of the case. So it will also help you in long term. If you get the vitamin D tested and you get some supplements and also some sunlight, it may help you in the long term. But for sure, like almost in India, even though people go out very often, almost 70% of Indians they have vitamin D deficiency. More than 70%. Okay, so also get tested for vitamin D. Chali. So you want to do the class or you want to take a leave? Sorry, Umar.
Sir, I thought you might be taking a test.
Yeah, I have to take a Viva. Yeah, right. You want to get a Viva?
Is it Viva or written test?
No, it is a Viva. I
Viva?
think I told you. See?
I see. Okay.
Last class में हमने कहा था ना?
Mm-hmm.
Viva on Wednesday.
Yeah.
Okay. So it's up to you, okay? If you want to take, otherwise we can.
Just send me the notes, okay?
Notes.
Yeah,
Oh,
notes.
okay, fine. I will send it.
Sure.
So take care, huh? Bye bye.
Yeah, I mean, I will stay here in the class.
You will stay in the class, okay?
I have nothing else to do, so.
Okay, sure, no problem. Okay, is everyone done?
Yes.
No, sir.
No? Okay, right. See, measurement is high, it means osmotic pressure, it will give you a large value, a direct value, okay? But if you compare the elevation in boiling point, now elevation in boiling point you can't do. Why? If you have to boil a particular solution, it will break the macromolecules, it will break the polymers. For NaCl type of solute, it is fine, it does not get broken and it does not what I can say. It does not get into fragments, but polymers and proteins, if you will heat it to a very large high temperature and 100 degrees Celsius, it will obviously break down. That is why you cannot use those things. And also depression in freezing point. Again, when you have to freeze it, that means you have to give it a particular condition, right? You have to set up many things. But for osmotic pressure, you don't have to set up those things. You just can measure the osmotic pressure. And also the measurement is high. And that is why it is used to determine the molar masses for macromolecules such as polymers and proteins. Chaliye, please write this down. Done now, all of you?
Yes, sir.
Okay, fine. You'll just write a question. Then we'll take the viva. Write the question. Okay, also remember, see, this one was also asked in CBSE examinations also. Okay. So in 2015, it was asked that which method, which qualitative properties used to calculate the molar masses of macromolecules. Okay, write another question. Why don't you use dark mode for one node? I'm comfortable with this only, Muhammad Umar. Please write. Okay, fine. I will take care. I will take a poll. If most of the students are okay with the black screen, then it will be fine. I have no problem. Okay, right. A solution prepared by dissolving 8.95 milligrams of a gene fragment in 35 ml. 35 ml of water has an osmotic pressure of 0.335 torr at 25 degrees Celsius. Assuming the gene fragment is non-electrolyte. Assuming the gene fragment is non-electrolyte, determine its molar mass. Okay. So read the question, all of you. Okay. Okay. Mohammed Umar, after we end this question, we will do a poll. Okay. You guys need help, huh? Abdurrahman, Fatima, Sarah, Huzaifa, Adriel. Just let me know, okay? You have the formula, right? You have the formula for the molar mass. How to calculate molar mass using osmotic pressure. Just keep in mind the units. You have to convert this milligram, you have to convert this ml, you have to convert this torr, you have to convert this degree Celsius to Kelvin. So for torr, I will just let you know. So pi is given as 0.335 torr, right? And this will be equal to 0.335 by 760 atm. Okay. Divide by 760 and we'll get the atm. The value of R that we are going to take will be 0.0821 liter atm per mole per Kelvin, per Kelvin per mole, per Kelvin per mole. See, Abdul Rahman, no, but see in this chapter, na, you will have either this liter atm per Kelvin per mole. See, if you have the volume as liters, please listen, Abdul Rahman, okay? If you have the osmotic pressure as atm, the temperature will always be in Kelvin and the number of moles will be always in mole. So if you have liter atm, then it will be 0.0821. But if it is liter bar per Kelvin per mole, then this will be 0.0831. Okay, 0.083 you can write, and for this also you can remember 0.082. Okay, Abdul Rahman.
Okay, sir.
Okay. I think all of you have written the question now. 11th में भी तो हमने ये चीज शायद कराई थी आप लोगों को, right? States of matter first में ही हमने second class में I think. Can all of you see this? क्या है ये? हाँ, अब्दुल रहमान, सारा,
Yes, sir.
क्या है ये? Same things, right? Yes or no? 11th में
Yes.
भी, 12th में भी, फिर भी नहीं आता है, फिर भी भूल जाते हैं बच्चे. फाइनली हमने प्रेशर के बारे में कहीं तो लिखाया होगा आप लोगों को. हाँ, सी यूनिट्स ऑफ प्रेशर है यहाँ पे, है ना? So 1 atm is equal to 760 torr. चलिए, नॉस्टैल्जिया काफी हो गया. Let us back here. That's it, no? Don't have to do anything else. Pi is equal to CRT. Okay, now listen all of you. ऐसे केसेस में क्या कीजिएगा आप लोग? You will approximate, okay? 8.95 को क्या ले सकते हैं हम लोग? 9 into 0.0821 इसको लिखिए सबसे पहले 821 into 10 to the power minus 3 into 298.15 को 300 ले लीजिए into 760, okay? 0.335 है 335 into 10 to the power minus 3, right? Into 35. चलिए अब you can cancel this and this. आप कैलकुलेट कीजिए जल्दी 2 मिनट के अंदर, जल्दी कीजिए अब यहाँ से. It's not any more difficult now. किसी का नहीं आया आंसर? चलिए 1 more minute, then I will write the answer. Excuse me, sorry. By the way, all of your schools must be on offline now, right? Is there anyone who is going online? No one. Okay, good. Mohammed Umar, offline na?
Yes, sir.
How is it going?
It's going well.
Going well. Okay.
Yeah.
When is your vacation starting?
I told you, right? First
At the end.
June 30.
At the end now.
Yeah. And
There's some schools which are having on mid of June also na?
yeah, there are some.
Some schools which happen mid of June. क्या वो आंसर ही नहीं आ रहा किसी का? अब्दुल रहमान, Okay, Sarah. Sending. Okay. So it is approximately 14193 grams per mole. The exact one.